A pleasant day, everyone. Today, we will be solving two problems from the book Fundamentals of Analytical Chemistry. So, what will be the content of this presentation? First is the problem 2414, Objectives and Procedures. Second, problem 2414, Question and Calculations. Third, problem 2414, Results, Analysis, and Conclusions. Fourth, problem 2617, Objectives and Procedures. Fifth, problem 2617, Question and Calculations. And lastly, sixth, problem 2617, Results, Analysis, and Conclusions. So, for problem 2414, Objectives and Procedure. First objective, to find out the formula that would be used to calculate the percent transmittance. Second objective, to calculate for the percent transmittance using the formula and the given absorbances. Third objective, to know the relationship between absorbance and percent transmittance. For the procedure, first is to gather formulas. Gather all necessary equations for formulas that would be used to find out the formula for percent transmittance. Second is to derive the formula. From the gathered formulas, derive the formula for percent transmittance. Third, to substitute the given. To find the percent transmittance by substituting the given absorbance values. Fourth, record the values. Record the values that were calculated when the given absorbances were substituted. Fifth, plot the values. Plot the percent transmittance versus the absorbance values for observation of data. Lastly, to identify the relationship from the plot of the percent transmittance versus absorbance values, identify their relationship. So here, we can see here, the P sub 0 is the initial amount or the original amount, the initial amount, and the P here is the amount or how much successfully passed through the medium, solution, or substance. So the formula for transmittance, T is equal to P over P sub 0. So the relationship of percent transmittance to transmittance, percent transmittance is equal to 100T. Or in terms of T, T is equal to percent T over 100. So from the formula for absorbance, we can get the formula for percent transmittance. So here, absorbance is equal to log of P sub 0 over P. So from the formula of absorbance, we can use the relationship of the formula of transmittance and the relationship of transmittance to percent transmittance. So here we can see P sub 0 and P over P, which is the reciprocal of the formula for transmittance. And since it is the reciprocal, we can say that we can substitute the reciprocal of T, since this here is the reciprocal of the formula for transmittance. So substituting the reciprocal, we get A is equal to log of 1 over T. So from the 1 over T, we can say that this is the reciprocal of T, which in return is percent T over 100. So we will get the reciprocal of percent T over 100 and substitute it, and we will get A is equal to log of 100 over percent T. So from here, we can already derive the formula for the percent T, or simplify it, then derive it. Either way, we can get the formula for percent T. So if we simplify it, we get A is equal to 2 minus log of percent T. So now we get the formula for percent transmittance by deriving both equations. For the first equation, A is equal to log of 100 over percent T. So we get the anti-log of both sides. We'll get anti-log of A is equal to 100 over percent T. Now getting the reciprocal of both sides, since percent T is below. So we get anti-log of negative A is equal to percent T over 100. Now from here, we can get the percent T, which is equal to percent T is equal to 100 times anti-log of negative A, or percent T is equal to 100 times 10 raised to negative A. So deriving the second formula, A is equal to 2 minus log of percent T. We subtract 2 from both sides. We get A minus 2 is equal to negative log of percent T. Now dividing both sides by negative 1, so we eliminate negative 1. So we eliminate the negative sign. In the right side, we get 2 minus A is equal to log of percent T. Now from here, we can get the second formula for percent T, which is equal to percent T is equal to anti-log of 2 minus A, or percent T is equal to 10 raised to 2 minus A. So we now have the two formulas that we will be using for calculating the percent transmittance with the given absorbance values. So our absorbance values express the following absorbances in terms of percent transmittance: A 0.0356, B 0.895, C 0.379, D 0.167, E 0.485, and lastly F 0.753. So we'll be using the two formulas to get the percent T, and by substituting the absorbance values, we get 92.13% T for A, which is the same here in the second formula, 12.74% T for B, 41.78% T for C. Next, I won't elaborate more because we use the same formula from A, B, and C. So we get 68.08% T for D, 32.73% T for E, 17.66% T for F. Now, the results, the summary of results. For A, we get 92.13% T. For B, we get 12.74% T. For C, we get 41.78% T. For D, we get 68.08% T. For E, we get 32.73% T. For F, we get 17.66% T. Now for our analysis, we plot the percent T, percent transmittance versus the absorbance. And we get this line, which is heading down to the right. So for the analysis, from the plot of absorbance values and the percent transmittances, it can be observed that as the value of absorbance increases, then the value of percent transmittance decreases. And lastly, for our conclusions, for problem 2414, the formula for percent transmittance is 100 times anti-log of negative absorbance or anti-log of 2 minus absorbance. The percent T for given absorbance values can be calculated from the formula of percent T, which I stated earlier. And last conclusion, from the plot of absorbance values and percent transmittance, it can be concluded that their relationship is inversely proportional. Now, for our second problem, our objectives. First objective is to identify the formula that would be used for calculating the concentrations of nickel and cobalt in the solutions. Our second objective, to calculate for the concentrations of nickel and cobalt in the solutions with the formula and the given values of path length, molar absorptivities, absorbances at 360 nanometer and 700 nanometer. Third objective is to identify the relationship of concentrations of nickel and cobalt to the absorbance values at 360 nanometer and 700 nanometer. For our procedure, first, the formula that would be used for the calculations of concentrations of cobalt and nickel must be identified. Second, substitute the values from the formula that was identified. From the formula that was identified, the given values can be substituted to it to arrive at the computed concentrations of cobalt and nickel. Next, the concentrations of cobalt and nickel that were calculated would be recorded and analyzed by plotting the concentrations versus the absorbance values. And lastly, we need to identify the relationship. From the plot that was created, the relationship of the concentrations to the absorbance values can be identified. Now for the problem, A.J. Mukherjee and N.V. Deshpande report on a simultaneous determination for cobalt and nickel based on absorption by their 8 quinolinol complexes Molar absorptivities are 3,529 for cobalt and 3,228 for nickel at 365 nanometer and 428.9 for cobalt and 0 for nickel at 700 nanometer. Calculate the concentration of nickel and cobalt in each of the following solutions with 1 centimeter cells. For solution 1, 0.617 and 0.0235. For solution 2, 0.755 and 0.0714. For solution 3, 0.920 and 0.0945. For our fourth solution, 0.592 and 0.0147. And lastly, for our fifth solution, 0.685 and 0.0540. Proceeding to our calculations. First, we will be getting the formula for the concentration of cobalt and the concentration of nickel. We'll be using the formula for absorbance, which is equal to B times molar absorptivity of X times the concentration plus B times the molar absorptivity of Y times the concentration of Y. So we will be substituting all the given, the molar absorptivities to the formula with RB, which is equal to 1 centimeter. After substituting it, we can see here A sub 700 is equal to quantity 428.9 times 1 times concentration of cobalt plus quantity 0 times 1 times concentration of nickel, which when simplified is equal to A sub 700 is equal to 428.9 times concentration of cobalt. And we get the formula for concentration of cobalt, which is equal to the absorbance at 700 nanometer over 428.9. Now we have the formula for the concentration of cobalt that would be used for calculating the concentration of nickel. When we get the concentration of cobalt, we will be substituting it here in the formula for the concentration of nickel, simplifying the substituted values. We get concentration of nickel is equal to absorbance at 365 nanometer minus quantity 3,529 times concentration of cobalt over 3,228. So we have the formula for concentration of cobalt and concentration of nickel at given absorbances in different nanometers. So we will be calculating the concentration of nickel and cobalt. So for our solution 1, We just substitute the values, and we get the concentration of cobalt, which is 5.48 times 10 to the negative 5. For the concentration of nickel, we get 1.31 times 10 to the negative 4. Using the same formula for solution 2, we get concentration of cobalt is equal to 1.66 times 10 to the negative 4, and concentration of nickel is equal to 5.24 times 10 to the negative 5. Using the same formulas for solution 2, 3, 4, and 5, we will get the concentration. I will not elaborate more because we use the same formula. For our solution 3, we get concentration of cobalt is equal to 2.2 times 10 to the negative 4. Concentration of nickel is equal to 4.45 times 10 to the negative 5. For our solution 4, we get concentration of cobalt is equal to 3.43 times 10 to the negative 5, and concentration of nickel, which is equal to 1.46 times 10 to the negative 4. And lastly, for our solution 5, we get concentration of cobalt is equal to 1.26 times 10 to the negative 4, concentration of nickel, which is equal to 7.45 times 10 to the negative 5. So now, for our summary of results, for solution 1, we get concentration of cobalt is equal to 5.48 times 10 to the negative 5. Concentration of nickel is equal to 1.31 times 10 to the negative 4. Solution 2, we get concentration of cobalt is equal to 1.66 times 10 to the negative 4. Concentration of nickel is equal to 5.24 times 10 to the negative 5. Solution 3, we got concentration of cobalt is equal to 2.2 times 10 to the negative 4, and concentration of nickel is equal to 4.45 times 10 to the negative 5. For solution 4, we get concentration of cobalt is equal to 3.43 times 10 to the negative 5. Concentration of nickel is equal to 1.46 times 10 to the negative 4. And lastly, for our solution 5, we get concentration of cobalt is equal to 1.26 times 10 to the negative 4, and concentration of nickel is equal to 7.45 times 10 to the negative 5. So here are the concentrations of cobalt and nickel and different solutions with different absorbances at different nanometers. For the analysis, we plot the absorbance values at 365 nanometer and 700 nanometer versus the concentrations of cobalt and nickel. So the plot of cobalt versus the absorbance values, it shows the blue line and the yellow line shows it is heading upward to the right, while the plot of nickel, which is the gray, and the orange one shows it is heading downward to the right. From the plot of the absorbance values and the concentrations at 365 nanometer and 700 nanometer, it can be observed that as the value of concentration of nickel increases, then the value of absorbance decreases, while as the value of concentration of cobalt increases, then the value of absorbance also increases. For our conclusion, The formula for concentration of nickel and cobalt can be derived from the formula for absorbance with two or more concentrations. The concentrations of nickel and cobalt at 365 nanometer and 700 nanometer can be calculated through the formula that was obtained. So from the plot of the absorbance values and concentrations at 365 nanometer and 700 nanometer, it can be concluded that the relationship of the absorbance in the solutions to the concentration of nickel and cobalt is inversely proportional and directly proportional respectively. So that's all. Thank you for listening.